Hello again to the last and sixth unit of this week, the deep dives. Here we will concentrate on three topics. One is demand management, the second is available to promise functionality, and the third is the task management in general. The first deep dive topic, demand management, is closely related to the first two units, demand planning and supply planning. With demand management, we describe the functions that define how forecasts and the actual demand are considered in supply planning. Remember that the demand forecast was used to drive supply planning if the actual demand is not known yet. That, on the other hand, means as soon as actual demand is entered in the system, we need to define the impact on the forecasted quantity in order not to overestimate the demand. These calculations are done in a certain granularity of the forecast buckets, either in weeks or months. To control the behavior, we offer the demand management procedures. Per product, you can control how forecast is consumed or reduced by actual demand. With consumption, we mean that a certain forecast quantity is not considered for supply planning anymore. The first three demand management procedures consider actual demand, but differ only in the bucket for which the consumption takes place. In the fourth procedure, all demand reduces forecast. The actual demand is not considered in supply planning. Forecast is reduced as soon as the quantity is delivered to the customer. Now, in the next slide, I will illustrate the first three demand management procedures. In the three figures, you see in blue the forecast that are placed on top of the timeline. In yellow, you see the actual demand at the bottom of the timeline. And green is the consumed part of the forecast. The dotted line separates the buckets. The first graphic for demand consumes current forecast shows that the demand consumes the forecast of the same bucket. If the actual demand is in May, only the May forecast is consumed. The second graphic for demand consumes adjacent forecast explains that the demand consumes the forecast in the same bucket, one bucket backward and one forward, meaning if the actual demand is in May, so the consumption takes place first in May and then in April or June forecast. And the third graphic for demand consumes preceding forecast explains that the demand consumes the forecast in the same bucket and all backward buckets. In our example, actual demand is in May. First, it would consume May forecast and next April forecast. Now we'll have a deeper look into the second deep dive topic, available to promise or ATP. In Unit 5, we already have seen in the system how the result of an ATP check is displayed in a sales order. Here I would like to give you some details on how it's calculated. The purpose of this is obvious. When customers order, they expect a reliable confirmation whether the product is available in time and quantity. The available to promise process consists of three main parts. First, the determination of the ship from site, which was explained in week 1. Second, the shipment scheduling. Transportation duration and internal preparation time is important to calculate the start date of the logistic execution activities. This is also the entry point for the third part, the core product availability check. As a result, the ATP determines the dates and quantities we can confirm to the customer. Even without the product availability check, this results in a confirmation, but done purely based on the shipment scheduling as displayed with the dotted line in the graph. The confirmation update run recalculates confirmations for a set of sales orders, for example, to distribute quantities amongst these to consider changed supply situations. Now I would like to focus on the shipment scheduling, assuming the ship from site is determined. The shipment scheduling starts with the backward scheduling. The customer order item comes with the product quantity and its requested delivery date information, as well as the ship to address. The ship from Site and transport lane is determined first. Based on the requested delivery date displayed in number 1 in the graphic, the shipment duration is used to calculate when the goods should be shipped. The result is the requested shipment date, reflected as number 2. This is the date when the goods have to leave the site to be on time. Next, the goods issue processing time is taken into account. It is the lead time required to prepare the shipment of the goods in the warehouse. It results in the requested execution start date, number 3. With this requested date, the product availability check is performed. I will explain the details how it's calculated in the next slides. Anyway, it returns the confirmed execution start dates. If the confirmed execution start date is same as requested, the shipment and delivery dates stay the same. If the confirmed execution start date is further in the future, represented by number 4, then a forward scheduling is performed to compute the confirmed shipment date and the confirmed delivery date, represented by number 5 and 6. If there is no availability check method maintained for the product, then the forward scheduling is triggered from the today's line if the requested execution start date is in the past. Now let's have a closer look at the product availability check itself. The product availability check ensures the accuracy of the confirmation date and quantity by checking the customer requirement against the stock on hand and the product supply situation, as well as the delivery rules. With the availability check scope, you can select which types of supply is included for the product availability check. It's illustrated in the figure on the left side. On the vertical axis, it's displayed all supply related to external procurement. On the horizontal axis, you see the supply provided through in-house production. For both, the availability check scope is relevant in a similar manner. You can use only stock as supply. On one hand, this will result in a very reliable confirmation. On the other hand, it easily results in an unconfirmed situation, although you might have enough time to reorder. Therefore, it might make sense to include stock and related receipts. This incorporates purchase requests, purchase orders, and ASNs on the external procurement side and production requests for in-house production. You can extend the check scope even more by adding the firm and unfirm purchase and production proposals. The outcome of the product availability check is a set of confirmed schedule lines and quantities considering the restrictions that are derived from the delivery rules. The figure on the right side visualizes an example for the check scope, stock, and released receipts. The sales order 1 can be confirmed on time based on the stock on hand and on the ASN from the supplier. A later incoming sales order can only be confirmed late based on the purchase order. If the availability check scope would be only available stock, the sales order 1 would have been only partially confirmed or exactly 2/3 of the quantity. The second sales order would not have been confirmed at all. Using a check scope including recipients implies that those receipts are properly planned. This is normally only valid for a certain horizon. SAP Business by Design therefore offers check methods where the check horizon can be specified together with the availability check scope. The check scope and the corresponding horizon are indicated with 1 and 2 in the graphic. If the requested date is inside the check horizon and no quantity is available, the confirmation is pushed out to the check horizon date. This leads us to another question. Is the check horizon date good enough to be used as the confirmation date, or does it even take longer to replenish the goods? Therefore, another parameter, the replenishment lead time, is introduced. It describes the time it takes to procure or manufacture goods. It can be combined with the check methods, including the check horizon represented by number 4. A sales order with the requested date between the check horizon and the replenishment lead time is therefore confirmed at the end of the day of the replenishment lead time. If the sales order is checked later again, the confirmed dates and quantities are not changed until the requested date enters the check horizon. Then, if the quantity can still not be confirmed, the quantity is confirmed at the check horizon. You can also use the replenishment lead time without a check scope. This especially makes sense for make-to-order scenarios where you do not have any supply available upfront. This is lower here. The last subtopic of ATP is the confirmation update run. Its purpose is to consider the changes in the product supply situation. For example, if the stock on hand is less than expected, or to give priority to a more recent sales order. The latter is explained on the picture on the right side. The first sales order confirms against the stock in Figure 1. In Figure 2, you see the second sales order, which has an earlier requested date. It is confirmed against the purchase proposal, which was created meanwhile and which is scheduled after the requested customer date. It's a first-come, first-served approach. Through a better organization, both sales orders could get their requested quantities in time. The confirmation update run reorganizes the confirmation and reallocates the available quantity to the customer demand selected for the update run, visualized in Figure 3. The confirmation update run is a variant of the product availability check. You can use sorting parameters affecting the sequence in which the customer demand is checked and confirmed, for example, the items for complete delivery first, or sorting according to the requested delivery date. For exceptional manual interference, in case of an urgent need to prefer one customer to another, the confirmation for one customer can be cancelled and given to another customer with a manual initiated availability check. With this, I close the ATP topic and move to our third and last topic, which is task management. Logistics task management is designed to organize your day-to-day work in warehouse and production in a standardized way. You can define suitable work packages and structure the processing of all logistics and production tasks accordingly. In case of exceptions, at a task confirmation, the manager gets an exception list for resolving or deciding. The first part of the task management, of course, is the logistics or production task itself. We have seen that they are created for various processes. They are dispatched to the logistics task folder that helps to organize pending work and represent the work lists for one or more workers. You can create your own task folder depending on various criteria. For example, for the warehouse task, you can assign task types collecting the pick or the put away tasks. Or you can assign storage areas in case a specific warehouse worker is responsible for the valuable goods storage area. The assignment criteria differ for production task folders and count task folders. The person responsible for a task folder registers for it. In the example, it is the put away task folder. Additionally, he or she can work on pick's task to help out. And last but not least, the manager can monitor and control the logistics tasks. The manager can regularly monitor the task fulfillment process and check which tasks are still in process at the end of the working day and take respective measures. In case of deviations due to missing parts in the goods issue process, when confirming the task, the manager gets informed and can take actions. When accepting the reduced quantity, the outbound delivery will be sent to the customer with the partial quantity. He might have manually to correct the inventory. The supply planner and the sales rep eventually have to follow up on the partial fulfillment. With reprocess the open quantities decision, the warehouse task opens again, trying to fulfill it once again. So what you have learned in this unit? I have shown you how actual demand can influence the reduction or consumption of the forecast. I have explained which aspects influence the calculation of the date and quantity that can be promised to the customer and how the task management concept works. With this week 2 ends, and the only thing which is left for me is to thank you for your participation. In case of questions regarding the planning, buying or selling process, I'm happy to answer these in the discussion forum. In the next week, my colleague Krishna will continue with product manufacturing. Thank you.